Hi everyone, and welcome to this video going over Advanced Functions Review. Today we're going to be talking about solving logarithmic equations, and we're going to be putting it in terms that is easy to understand and will help you on the exam. So what are we going over today? Well, first we're going to be going over what is a log. Then we're going to be going over the rules. And then finally we're going to be talking about how to solve equations involving logarithms. Something that has always helped me out when thinking about what is a log is remembering that a log is an exponent. Remembering it this way has really helped me out. So let's see it in action. If we have log base 2 of 8 and we want to know what that equals, we can just remember that a log is an exponent. So this means x is the number that we need to raise 2 by to equal 8. So a log is the exponent we have to raise the base by, in this case 2, to equal 8. And since we know that 2 to the power of 3 equals 8, this means that x is equal to 3. So by simply remembering that a log is an exponent, you can work your way through any difficult problem. So now let's go over some rules that we will use to solve logarithmic equations. First, we have the log of any base to that same number is equal to 1. Log of any base to 1 is equal to 0. Log base a of a to the power of n is equal to n. And we know this to be true because it's the same thing as saying n log base a of a. And from before, we know that log base a of a is equal to 1. Then we have a to the exponent of log base a x is equal to x. Log base a of m divided by n is equal to log base a of m minus log base a of n. This is similar to how log base a of m times n is equal to log base a of m plus log base a of n. And when we have log base a of m to the exponent of n, this is the same thing as saying n log base a of m. But sometimes you may need to change the base of the log. To change the base, use this formula. Log base a of b is equal to log base c of b divided by log base c of a. This is still the same as before, but the base has now been changed to the number that you require. Now let's implement these rules. If log x plus y over 5 equals 1/2 log x plus log y, where x is greater than 0 and y is greater than 0, show that x squared plus y squared equals 23xy. You can pause this here and give it a try. So how do we go about solving this? Well, what the question is really asking you to do is to simplify the equation to show that it equals x squared plus y squared equals 23xy, which we can achieve by manipulating the equation. Using the formulas we know, we can show that log x plus y over 5 is the same thing as log x plus y minus log 5. And using another formula, we know that log x plus y minus log 5 is equal to 1/2 times log xy. When we divide both sides by 1/2, we get 2 log x plus y minus 2 log 5 equals log xy. This is the same as saying log x plus y squared minus log 25 equals log xy. To simplify this further, log x plus y squared divided by 25 equals log xy. Since the logs on both sides are equal to one another, we can get rid of them. So now this equation is x plus y squared over 25 equals xy. From here, it's simple algebra. First, we'll multiply both sides by 25 to give x plus y squared equals 25xy. Next, we'll break down x plus y squared into x plus y times x plus y equals 25xy. This will make it easier to expand into x squared plus 2xy plus y squared equals 25xy. Then by subtracting 2xy from both sides, you get x squared plus y squared equals 23xy, which is the answer we were looking for all along. Now give this question a try. If log base 16 of 7 equals m and log base 8 of 11 equals n, what is log base 2 of 77 in terms of m and n? We're going to need to change each of the logs into log base 2, so let's recall the equation for changing the base. First, let's start with log base 16 of 7. This changes into log base 2 of 7 divided by log base 2 of 16, which is the same thing as 4. By multiplying both sides by 4, we get log base 2 of 7 equals 4m. To change log base 8 of 11 into a base of 2, we'll need to do log base 2 of 11 divided by log base 2 of 8, which is the same thing as 3. So then the entire equation is equal to log base 2 of 11 equals 3n. But how does this fit into log base 2 of 77? We're going to have to manipulate the equation a little bit. So log base 2 of 77 is equal to log base 2 of 7 times 11. And by using one of the formulas, we know that this is equal to log base 2 of 7 plus log base 2 of 11. These are the same numbers that we derived earlier, so then this is equal to 4m plus 3n. And there you have it. That's log base 2 of 77 in terms of m and n. Thanks so much for watching, and I hope that this was somewhat helpful in helping you review.